As I mentioned in the last lesson, creating multi-thread programs just by using the thread class alone won't work, because if we have an object-oriented program with derived classes, those classes cannot derive both from their base class and from the thread class. So the solution is to implement the runnable interface. So in this lesson, I'm going to show you how to take the program we wrote in the last lesson and implement runnable. So the first thing we're going to do is we're going to copy tothreads.java to runnable tthreads.java. Runnable tthreads.java. So the first thing we need to do is change that name, runnable tthreads. Now there are a couple of changes we have to make. Let's go down to our classes first. And rather than extend thread, what we're going to do is we're going to have to write implements runnable to indicate that we are now implementing the runnable interface. And by the way, when we do that, runnable gives us the methods that we need to start and stop threads and just in general work with threads. So we also need to modify compute log, like so. Most of our work, though, is going to be in the main program. First thing we have to change is how we create the threads. Rather than write thread first thread equals new user interaction, we're going to have to write thread first thread equals new thread. We're still using threads, but in a different way. New user interaction. So we call the thread constructor, and then inside the thread constructor, we call our class constructor. Then we start the first thread the same way we normally would. Now, for the next class, compute log, we're going to do this a little different also. We're going to write compute log, we'll call it numproc for numeric processing, equals new compute log. That's the first step. Then we write new thread is equal to new thread numproc, like so. Then we start the second thread. We've already started the first thread. We start the second thread, we join the first thread, and now all we have to do to end the second thread is call numproc end. So really this makes our programming a little bit easier to understand. So let's save the file. Go back to our command prompt. One other change we have to make is we also have to change how we make our threads sleep. So right here where we have sleep 1, that needs to become like so. Now, go back to our command prompt, compile again. There we go. And there's our program. So, runnable interface gives us a means of creating classes that can be multi-threaded but also be derived from other base classes. And that's important when we're writing more complex object-oriented programming. And with that, we wrap up this lesson on the runnable interface, and we'll move on and look at some more examples of writing concurrent programs.